Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of game theory with engineering applications. We'll dive into key concepts like specificity of rules, rules of digital games, case studies, tic-tac-toe, deck of cards. Let's get started. Slide 1. Specificity of rules. Explanation. The concept of specificity in game rules refers to how well-defined and unambiguous the rules are. Specific rules ensure that all players understand the mechanics of the game, preventing misinterpretations and disputes. 1. Ensures fairness and consistency. When rules are clear and precise, all players follow the same conditions, creating a balanced and competitive environment. 2. Defines player actions explicitly. Every possible action is predefined. For example, in chess, a bishop can only move diagonally, and this rule never changes. 3. Reduces rule exploitation. If rules are too vague, players might find loopholes that could make the game unfair. Specific rules prevent such exploits. 4. Improves automation in digital games. In computer-based games, the system needs clear instructions for processing player actions correctly. 5. Affects game difficulty and complexity. Well-defined rules can either make a game more challenging, by limiting player choices, or easier, by clarifying expected actions. 6. Enhances the learning curve. If rules are too complex or ambiguous, new players struggle. Specificity helps players grasp game mechanics faster. 7. Impacts adaptability. Games with highly rigid rules limit player creativity, whereas flexible rule systems allow for emergent gameplay, where players invent new strategies. Example. In chess, a knight moves in an L shape. This specific rule adds a unique movement mechanic that players must strategize around. Significance. Specificity in rules ensures a fair and structured gaming experience, which is crucial in competitive and digital environments where automation and fairness are necessary. Slide 2. Rules of digital games. Explanation. Unlike physical games, where human judgment can sometimes influence rule enforcement, digital games have strict, coded rules. These rules are built into the game mechanics and automatically enforced by the software. 1. Defined by programming logic, digital games are governed by algorithms that dictate how the game responds to player inputs. 2. Strict enforcement by the system. A digital game does not allow rule breaking unless explicitly programmed, e.g., cheat codes. 3. Includes physics engines and AI behavior. Game engines simulate real-world physics, gravity, collisions, and control AI opponents' behavior. 4. Determines player objectives and rewards. Win conditions, missions, and achievements are programmed to guide player progress. 5. Can be modified via patches and updates. Developers can adjust rules post-release, fixing exploits or rebalancing difficulty. 6. Handles multiplayer synchronization, ensures that all players in an online game experience the same events in real time. 7. Prevents cheating through built-in restrictions. Anti-cheat software and encrypted rules prevent players from altering game mechanics unfairly. Example. In a racing game, rules ensure that a player cannot drive through obstacles. The game engine enforces collision detection, making sure that cars respond realistically to crashes. Significance. Digital games require precisely defined rules because the software must be able to execute every action programmatically. Without specificity, the game would be unpredictable and unplayable. Slide 3. Case study, tic-tac-toe. Explanation. Tic-tac-toe is a simple, turn-based strategy game that demonstrates the importance of predefined rules and deterministic gameplay. 1. Two players take alternate turns. There is no randomness, each move is based on the player's decision. 2. The game board is a 3x3 grid, a fixed layout ensures simplicity and strategic depth. 3. A player wins by forming a row, column, or diagonal of their mark. The primary objective is clearly defined. 4. If all spaces are filled without a winner, the game is a draw. The game has a defined endpoint, preventing indefinite play. 5. Moves cannot be undone. This maintains fairness and prevents backtracking. 6. Has a deterministic strategy. With optimal play, the game can always end in a win or draw. 7. Used in AI and machine learning studies. Since tic-tac-toe has a finite number of possible moves, AI can be trained to play it perfectly. Example. A common optimal strategy is for player 1 to place X in the center. This maximizes their control over the board. Significance. Tic-tac-toe is an essential learning tool in AI development, as it demonstrates how an algorithm can evaluate all possible moves and predict the best one. Slide 4. Case study, deck of cards. Explanation. A deck of cards provides a framework for various games, each with its own rule set. Unlike tic-tac-toe, card games introduce elements of probability and randomness. 1. Composed of 52 standard cards, the deck consists of 4 suits, each with 13 ranks, creating multiple game possibilities. 2. Games vary based on rule sets. Poker, rummy, and solitaire all use the same deck but have different mechanics. 3. Probability plays a major role. Players make decisions based on known and unknown information. 4. Skill and luck-based dynamics. Some games require strategic thinking, while others depend on chance. 5. Rules dictate shuffling, dealing, and turns, ensures fairness in card distribution and gameplay. 6. Commonly used in AI and probability research, card games are often used to model decision-making under uncertainty. 7. Some games have bluffing elements. In games like poker, psychological tactics influence outcomes as much as the cards. Example. In poker, a player with a weak hand can still win by bluffing, demonstrating that strategy is as important as probability. Significance. Card games illustrate complex decision-making scenarios, making them useful for AI training and probability modeling. Slide 5. Differences between tic-tac-toe and deck of cards. 1. Game type. Tic-tac-toe is a turn-based strategy game, where each player makes a move one at a time, with no randomness. A deck of cards is used for probability and strategy-based games, where randomness plays a role, and decision-making involves hidden information. 2. Complexity. Tic-tac-toe has a low complexity because it has a limited number of possible moves, only 9 positions on a 3x3 grid. Card games can be highly complex, as they involve multiple possible game types, strategies, and randomness in card distribution. 3. Skill versus luck. Tic-tac-toe is a pure skill-based game. With optimal play, a player can always force a win or a draw. Card games have a mix of skill and chance. While players can strategize, they also rely on the luck of the draw. 4. Number of players. Tic-tac-toe is strictly a 2-player game. Deck of cards games can have 1 to multiple players, depending on the type of game, e.g., solitaire is solo, poker can have multiple players. 5. Decision-making. Tic-tac-toe is deterministic, meaning that with perfect knowledge, a player can predict the entire game's outcome. Card games involve uncertainty, as players do not know their opponent's cards and must make decisions based on probabilities. 6. AI applications. AI in tic-tac-toe uses decision trees, evaluating all possible board positions to play optimally. AI in card games is far more advanced, using probability modeling and even bluff detection to make strategic decisions in games like poker. 7. Physical versus digital. Tic-tac-toe is simple to implement in a digital format, as the rules and moves are straightforward. Card games are more complex digitally, since they require randomness, shuffling, hidden information, and sometimes multiplayer synchronization. Key takeaways. Tic-tac-toe is fully predictable, whereas card games involve randomness and decision-making under uncertainty. AI in tic-tac-toe is simple, while AI for card games is much more complex, requiring advanced strategies like bluff detection and probability calculations. Tic-tac-toe has a fixed set of moves, whereas card games have nearly infinite variations, making them more dynamic and unpredictable. This comparison helps us understand how different types of games influence player decision-making, strategy formulation, and even artificial intelligence design. Example: a chess-playing AI can evaluate every possible move, just like tic-tac-toe. However, a poker AI must deal with hidden cards, probabilities, and bluffing, making it much harder to program.